everybody, it's Mrs. Pound, and we are starting a new chapter, chapter 5, on Newton's second law of motion. We've just finished covering Newton's first law, which was about inertia, and this law is going to be about force and acceleration. Okay, so our objectives are going to be to state the relation between acceleration and net force, state the relation between acceleration and mass, distinguish between the concepts of directly proportional and inversely proportional, because we're going to keep using those, and to state and explain Newton's second law of motion. So let's get started. So the introduction, I just want to remind you of a few things. First of all, the equation for acceleration. A equals delta V over delta T, or acceleration equals the change in velocity over the change in time. Don't forget that equation. Also, remember that the cause of acceleration is a force. So the reason a cannonball would accelerate is because force is applied to it in the cannon from an explosion that takes place in the cannon. So let's talk about section 5.1, the fact that force causes acceleration. The first thing we need to know is that an object's acceleration is directly proportional to the net force acting on it. Therefore, acceleration in that little tilde means that it's proportional to net force. It's not equal, but it is proportional. And so I have two up arrows. That means that if the acceleration goes up, the force goes up. So if one goes up, the other goes up. If the acceleration is lower, the force is also lower. So it works the other way around as well. So if both numbers are big, if one number is big, the other number is going to be big. If one number is small, the other number is going to be small. This is why guns are so dangerous. If you think about it, that little bullet or a little BB, if I just throw it at somebody, it's not very harmful. It won't do any damage. But if I put it in a gun and apply a great deal of force to it from an explosion in the gun chamber or in the cartridge, in the bullet, that can kill somebody. It can penetrate skin, it can penetrate walls, it can go through a glass window, things like that. It becomes very dangerous because a large force is applied to it that accelerates it very fast, and that force is transferred to the bullet or the BB. And so if you double the force on an object, the acceleration of the object doubles. Also, if you triple the force on an object, the acceleration triples. And with a gun, that's even more. You know, if you're probably like it's probably 100-fold the force on the bullet, so it's accelerating like 100-fold. It's very, very fast. And so that is why a bullet, something very, very small, can be very, very harmful and dangerous. Now, let's talk about, from section 5.2, the fact that mass resists acceleration. So, another relationship we can't have is things can be inversely proportional. This means two values change in opposite directions. So that means if one goes up, the other goes down, okay? Or if one goes down, the other goes up. They change in opposite directions. So we can say that the acceleration produced is inversely proportional to the mass. And this is represented by acceleration, the little tilde, 1 over mass. This is to show that something is inversely proportional. We write it as 1 over the number. It's the inverse, like in math, right? So let's say a force is applied to twice as much mass, and that results in half the acceleration. Let's think of some things that are about the same size. Let's say like a basketball and a bowling ball. about the same size, right? Or we could even say a volleyball. Maybe a volleyball is closer to the same size as a bowling ball. If we applied the same force to the volleyball and also to the bowling ball, which would accelerate faster? Well, it would be the volleyball because it has less mass. It has also less inertia, right? It takes less to get it going. The bowling ball would not accelerate as fast with the same amount of force. So we could also say a force applied to 3 times the mass results in 1/3 the acceleration. So let's say the bowling ball is 10 times the mass of the volleyball. That means the bowling ball will have 1/10 the acceleration of the volleyball. So that brings us to summing up what we have just been talking about, and that's what Newton's second law does. Newton's second law in words is the acceleration produced by a net force on an object is directly proportional to the magnitude of the net force, is in the same direction as the net force, and is inversely proportional to the mass of the object. So we just summed up everything we just said, but we also added something about the direction, which is really important. Okay? Newton's second law is an equation is written as acceleration equals net force over mass. Sometimes, and you could put this in our triangle, I'll show you that in class. Sometimes you see this as F equals ma. I have it written this way more to show our proportions here, but a lot of times you see this as F equals ma because if we multiply both sides by m, that's what we end up with. So you can rearrange this equation. Now, I said, I want to emphasize this again, that the net force acting on an object and its resulting acceleration are always in the same direction. So if you apply a force to something, if you push it, it's going to go forward. It's not going to go backward or off to some side. You know what direction it's going to be. Like when you're bowling and you apply force to the bowling ball, you know it's going to roll down the lane. And if it doesn't, that's because you didn't apply your force correctly, right? You made a little mistake and it goes in the direction you point in. The same thing when you're playing sports. That's why follow through is important. When you're throwing a ball, the ball goes in the direction that your hand goes in because that's the way you applied the force. So that's the importance of why it's important to follow through because your hand will point in the direction that the ball is going to go. So our objectives today were to state the relation between acceleration and net force, state the relation between acceleration and mass, and to distinguish between the concepts of directly proportional and inversely proportional, and state and explain Newton's second law of motion. So we have covered a lot of material and we'll be doing some things in class to clarify this.